How do you design the lab manuals and how do you come up with ideas?
Well, the general way of coming up with ideas for a course it stems a lot from the actual content of the course material. There are easier, there are more difficult courses. If I'm going to design something for optics, I'll take a look at what's actually being taught in the lectures and determine something from the learning objectives that fits in very well. I also consult the professor a lot, like Claudio Gradinaro, who's a professor for optics. I talk to him a lot about what he might require. One of the harder courses I have is Physics 324, the Advanced Physics Labs. It doesn't have lectures, and so it can be really difficult to determine what kind of material I should be putting into that course. And so generally, after discussing with Wagi Gobriel, I'll come up with something that has a fairly good educational outcome. And from that point, I have to design an actual experiment that fits this outcome. And that might be coming up with a new set of equipment. I also, basically just trawl the internet to pull ideas, or I talk to other colleagues at various universities. I've done that a few times. When I come up with an idea, and if I don't have the equipment, I either build it or buy it. Then I sit down, test every little bit of it, how easy it is to break it, because let's face it, students break everything. And while I'm doing that, I get a sense of what I want the students to do, and so I start writing that down. I also then write in there questions that they might have to consider that would actually make them learn something. I try to make it so that it's easy to mark from the perspective of a TA to varying degrees of success. And I then eventually, when it's in a good state, I'll grab an undergraduate student who hasn't done the course before or hasn't learned this material before and test it out on them. Watch them closely, make sure they're doing it all right, see how long it takes for them to do it, and make tweaks as necessary. After that, you run it by the professor, see if they have any changes, and add it to the course.
Amazing. Tell me about some of your labs that you have designed and in what courses they were in, and give me a little description of them.
So one of the more successful experiments that I've designed was the Frank Hertz experiment in the Advanced Physics Lab course. And now that was a different one than what I usually would have to design. For that one, the actual experiment only takes about 5 minutes, and it's everywhere on the internet, so everybody knows how to do it. So for that one, I actually had to sort of focus on more of the theory side, how you come up with an experiment as the educational objective. I get the students to analyze the two competing theories that led to that experiment, make predictions, and then I give them the equipment and say, great, now that you've made your predictions, find a way of actually testing those predictions with this equipment. And so the emphasis in that case isn't so much on doing an experiment from the past as it is on determining how to actually come up with an experiment, how to go from theory to confirming that through experimental physics, and gets them a better sense of this, something they haven't encountered before. And it's had great success with students. It's also one of my favorites for torturing them because they never do it right. But it definitely was a novel experience to try to put into the course. It also had its own issues with acquiring the equipment, but that's another long story. From optics, I've also had a success with the Build Your Own Laser Lab, or the Heaney Laser Lab as it's called there. And for that, I had an idea from a previous institution I worked at about doing a lab like that, and I thought it was a great experience for the students because they don't get a lot of introduction to how you actually build lasers, what goes into them, or the different components of it. So I went out and I found a kit for that online. I spent a long time figuring out all the different things you can do with that, many days and hours spent on that, and the best way to calibrate it, how to get good power outputs. And then I spent a lot of time on the internet reading about lasers. And in doing so, I discovered a bunch of things I wish the students would learn, and I put that into it. It was a little long in the first time I ran it, so I had to trim it down. I've gotten a number of inputs from various professors, so it's definitely a different position now than when it started. But I think it's come out for the best. And every time a student goes through it and says, I didn't get any from it, on this front. I have to change it around. If a TA says, this is terrible for me to mark, I have to change that. But generally it's a work in progress. It's a live, living thing that you update all the time.
Wonderful. Do you have any tips for first-year students who are new to doing labs and also writing lab reports?
Number one tip, read the manual. Always read the manual. Just because there's videos that exist doesn't mean that's the only thing you need to go from. Read the manual, do it step by step. We test these things out. We try to make it so that you understand. As for doing lab reports, ask your TA for guidance. If you're not doing it right, you get a low mark on one of the labs, ask your TA for guidance. Read their feedback. They're the ones who are marking it. They're going to know what to do. They're more than willing to sit down and help you through it. Not a lot of students do, and so they generally favor the ones that actually show that they're putting in the effort.
Amazing. Thank you so much for your time.
No problem.